The Web 3.0 space has absolutely exploded with opportunity. There's an insane demand for the people with the right technical skills to build the next generation of blockchain-based applications. But there's a common problem that people encounter whenever they get into the space. There's so many different ways to build blockchain applications and so many different libraries and frameworks to choose from. Sometimes this can feel completely overwhelming and you just don't even know where to start. Well, in this video, I'm going to compare two of the most popular libraries for interacting with blockchains, Web3.js and Ethers.js. I'm going to compare and contrast the two with actual coding examples and then talk about which one is best and how to get started learning each of these. I'm going to talk about this as a blockchain developer who works this technology on a daily basis and somebody who's helped thousands of people become real-world blockchain developers myself. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step-by-step start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so today we're going to compare and contrast Ethers.js and Web3.js and actually look at some coding examples to see how they're alike and how they're different. So really quickly, just a high-level overview of what each of these libraries are. They're both libraries for interacting with the Ethereum blockchain and also other EVM-compatible chains. This is where most blockchain applications are built in terms of like writing Solidity code and putting it out there, whether it's on Ethereum, Binance Smart Chain, Avalanche, you just name it, the EVM-compatible chain. And these libraries will mostly work. So Web3 is a really popular option. So is Ethers. You can see both the NPM downloads. We've seen a ton of momentum for Ethers actually pick up in the past few years or so. And it's actually surpassed Web3.js in terms of weekly downloads, which you can see here. And so this video, you're going to see why that's the case, why it's becoming kind of the preferred library among some developers, but ultimately how each library has a significant amount of usage across the entire ecosystem. So now I'm going to actually go through some of the coding examples to see how they're alike and how they're different. And then at the end of the video, I'm going to tell you my opinion on which one I think is best and which one I prefer. So let's jump in and get started. All right, so now let's actually jump into the code so that we can compare and contrast Web3.js versus Ethers.js. So I'm going to point to some repositories that are public on my GitHub here, okay? So I've actually done, tutorials on Web3.js and also Ethers.js and, kind of their high-level features, how you can get your hands dirty with each of them. And so we're actually going to look at some of those examples in this video to see, how they work, how they're alike, and how they're different, okay? So you can find each of these repositories. I'll put links down in the description below. This is the Ethers repository, and this is the Web3 repository. So I've got each of these projects pulled up side by side. I've got the Web3.js project on the left and the Ethers project on the right. Okay, so I'm not going to go through how to set up each of these projects and run through every single example in this video. The whole point is to show you how they're alike and how they're different. So if you want to follow the tutorials for each of those, you can find the YouTube videos associated with those. It's going to walk you through each and every example. But really, I just want to show you how they're alike and how they're different. So the first thing that I have here on the left is the Web3.js example that shows you how to do something really basic. Just fetch the Ether balance of an account. That's sort of like the smoke test that you do to make sure it's connected to the blockchain, okay? And I have the exact same code on the right. And the coding style is slightly different. This is a little more modern version of JavaScript with some syntax changes. This one's a little bit older tutorial. You could go through those and update the code if you wanted to, but you'll see how they're alike and how they're different. And so in this basic example, what we're going to see is how you actually connect to the blockchain with Ethers versus Web3.js. So you can see how they're alike and how they're different, and then how you basically just fetch this account balance. Okay. So essentially on the left here is the Web3.js model. So all we have to do to pull Web3.js in is we require it after we've installed it on our machine. We get an RPC URL. I'm just using the free Cloudflare ETH RPC link here. And then in order to get a Web3 provider, you just do Web3 new Web3 RPC URL. Okay. So Ethers.js is basically the same, just some slight syntax changes. You pull in Ethers like this. You give it the RPC URL, and then you create a new Ethers provider like this, Ethers providers JSON RPC provider, and then you pass in the RPC URL, okay? So it's the exact same thing, just with slightly different syntax. So not too big a difference there. So now we're going to do this example is take an address. I've just taken a random address from Etherscan, okay? And I've pulled in the, say let's do a variable in each example. On the left, you can see how you get the balance for this in Ethers. And on the right, you can see how we get the balance for it. Or excuse me, left is for Web3 and the right is for Ethers. So again, there's some syntax changes. We're doing the async await pattern here. little more modern way of doing this. A lot of JavaScript developers prefer this, so that's how we do it in the Ether side. And the Web3 version uses just a this callback function. So Web3.eth get balance. Okay, you pass in the address, and then you pass in this callback function, and then we take the balance and format it to the Ether value and log it to the console. And the same thing happens on the right. Okay. Basically, for Ethers, we say provider get balance, all right? And then we log it to the console, okay? So I'm actually going to run each of these examples. My terminal, I had the Web3 on the left. So let's say if you want to run the examples, you can do it like this. Samples, node examples 1, accounts, and then node examples 1, all right, accounts. And they both basically produce the exact same output. This one has a little more formatting on it, right? But they both produce the same number at the end of the day, okay? So one really quick thing to note here is one pattern that I see inside the Ethers library that a lot of developers prefer to the Web3 library is a little more elegance in the syntax, okay? It's less verbose. So like, for example, a lot of the Web3 stuff is nested under these, multiple namespaces here, like Web3, or Web3 ETH get balance, like everything's kind of nested under Web3 utils from way. And with Ethers, you already see it's just you take the provider and you just do get balance. Okay. Now we do have the same utility here, which is basically the same format: Ethers utils, format Ether, Web3 utils from way. There's similar nesting here, but this is a little bit more readable, I would say, for normal people. Just format Ether kind of makes more sense from way. You have to understand what way is. But if you're a developer, it doesn't make that big a difference, okay? But I see why some people prefer the elegance of the syntax in Ethers versus Web3, but that's just a simple thing. All right, so now let's look at another example to compare and contrast Web3 and Ethers. So in this example, we're going to look at how you actually talk to smart contracts. And in this case, what we're going to do is basically just read some information from a smart contract live from the Ethereum blockchain so that you can see how you can do it with each library and compare and contrast them. And this is where I think some of the differences really start to pop out. So what we're going to do is look at the DAI stablecoin, okay? So DAI is a cryptocurrency built on top of the Ethereum network. It's powered by a smart contract. It's an ERC20 token. And so this is a great way to see how you can, talk to smart contracts and just do really simple stuff. We're just going to read information. We're not going to make any transactions. That's the whole purpose of this particular section. So what we're going to do is just find a large DAI wallet and then read their balance and then read information about the DAI stablecoin, like the name, the symbol, total supply, and things like that. So basically, you'll see what the final output's going to be here. We'll just do node examples 2, read contracts, and then node examples 2. All right. And then you can see what the output's going to be. So here on the left for Web3.js, we see this is the symbol, it's DAI. The name of the cryptocurrency is DAI stablecoin. Here's the total supply. And then here is the balance, okay? So it looks like we're actually reading an account that doesn't have any DAI, so we can update that in a minute if we need to. But anyways, here's the DAI stablecoin symbol DAI. This one's got a little more syntactic, or I guess some better output, I should say. This one's kind of just simple, but they're basically returning the exact same information. So on the left, we have the Web3 way. So we have the exact same setup at the top of the file. Basically, we just import the Web3 library. We create a provider. Same thing for Ethers. This is the exact same as the previous example we looked at. Nothing different here. But here's where the difference really starts to pop out. So how we actually create a contract. All right. So with Web3, well, either way, either library, if you're going to talk to a smart contract, you need two pieces of information. The ABI, which is really just a big JSON object that describes how the smart contract works. And you need the address, okay? So you can see the DAI ABI on Etherscan. You can say like, let's see here. Let's go to the actual contract. This is the coin page. Go to the contract and you can see the source code. You can see the ABI. Really what this is just a big JSON object that lets you create a JavaScript version of the smart contract. It tells you like what the function names are, what the arguments are for each function, all right? Or whatever library, right? Let's say you're doing it in Python, it doesn't matter. It doesn't have to be JavaScript. But this ABI lets you create, a version of the contract that you can interact with in whatever language that you're choosing to talk to the smart contracts with. So the big difference with Ethers versus Web3 is that, the default way of doing it Web3 is you gotta import the entire ABI, okay? And with Ethers, what's really cool is that you can create an ABI like this with an array, and you can just pass in the Solidity source code for the interface, all right? So with Web3, you got to use the ABI. Of course, you could do subsets of the ABI. You can only import the functions that you want to, right? You don't have to copy the entire thing. We just copy the entire thing just for simplicity's sake. But, with Ethers, you can just use the Solidity functions, all right? And you don't have to necessarily know what the JSON ABI looks like. You can do this, all right? And I know a lot of developers really prefer this because then you can just pull in easily what you want to without having to do sort of the translation of what the Solidity functions look like versus what the JSON object for the ABI looks like. So this is a really common pattern for Ethers that a lot of people like. And here's sort of the default way of doing it with Web3. So you need the ABI, you need the address. This is a really cool way to do it in Ethers versus just copying and pasting the ABI. Does it really matter? Not really, but I know a lot of developers prefer this in Ethers and think that it's cool. So here's the address for the DAI token. So we have the ABI and the address, and we create the new contract. Basically, we say Web3 ETH contract, pass in the ABI, pass in the address. All right, and in Ethers, we do Ethers contract. Okay, so we're not necessarily, connect like here. We're connecting like we have the provider, and we're creating a new contract off of the provider already. And here, basically, we just do it off the Ethers object, create a new contract. We pass in the address, the ABI, and then we pass in the provider as a function call rather than reading it off this object, okay? So now when we actually execute the code, again, there's some syntactic differences. We're just using using the function calls with some callbacks, and here we're using actually an async await pattern where we use a function, an asynchronous function, and call everything one by one. So there's some slight, syntax differences here, some stylistic choices. Don't pay attention to those as much as just how each line works. So basically, whenever you are, here's where some of the elegance pops out with Ethers versus Web3.js. So you can see contract methods, total supply call, all right? And this is one reason that people like Ethers over Web3 is look how simple this is. So this is just name, await, contract name. A lot of developers get confused because they do contract methods total supply. I see this all the time. And then it just returns not what they expect. That's because anytime you're reading information from the smart contract, you have to add this call function to it because this is just going to return the function. It's not going to actually call it. So that's an extra step that kind of annoys people. And that's a big difference between Ethers and Web3, okay? Now, you can also see there's a little more verbose here. Like I was saying, it nests everything, inside of like this, a contract methods total supply, where this is just contract name, and it just calls it. If you use async await, like this is way less code than like this. And of course, you could definitely use async await in this context, but you'd still have, a lot of code to write to do the exact same thing. So that's kind of repeated over here. Total supply, name, symbol, balance of. So name, symbol, total supply, same code, different order. And then we log that out to the console. And yeah, that's the big difference between those two in terms of, interacting with the contract. You need less information or just different information, I should say. Not necessarily less because you could do less ABI here, but this is a little more straightforward by, with the Solidity code. And then the syntax for calling the functions is a little simpler as well. All right, so now let's talk about the function of actually sending cryptocurrency around from one account to another. In this case, we're talking about Ethereum cryptocurrency or Ether or like whatever EVM compatible chain you're talking about, like the actual crypto associated with that chain. So if you're on, Binance Smart Chain, it's the BNB token, et cetera, okay? But we're going to look at the Ethereum context now, so we're talking about Ether. Basically not an ERC20 token, but the native cryptocurrency of whatever that chain is, all right? So on the right, we're going to look at the Ethers example. I'm not going to run this entire example because you need to add like accounts and private keys, and there's a lot of setup steps involved. You can definitely go check out that full tutorial if you want to. But let's look at how you do it in Ethers first, then we'll talk about the Web3 way. So with Ethers, we have the same sort of setup. Basically, you just, connect to the blockchain like this. We talked about that in the previous sections. But then in order to actually send, cryptocurrency from one account to another, you need to be able to sign that transaction, all right? And you sign transactions with a private key. So a private key, the public key or your address can be deduced from the private key. The private key is like your password, so I don't want to paste a private key in here. But you would put a private key in your file or read it, from an environment variable or some sort of JSON key store, whatever, right? And then you would create a new wallet in Ethers like this. So you need to do an Ethers wallet, paste in your private key, and then have the provider. So the provider is here. And now with this wallet, you can sign transactions. This is what you need to do it. All right. And then basically we have a scenario where we have, sender and receiver, and we just log the balances before the transaction. But here's where you actually send the transaction. So what you do in Ethers is you just do wallet, send transaction, and then who you're sending it to, you put an object here. So account 2, you'd have a second wallet, and then you'd have the value. So this is the amount of ether you want to send, and you can do Ethers utils parse ether, and then put in the amount of ether you want to send, so 0.025. It will do the weigh conversion for you and put it in the format that it needs for the transaction to go through. Okay. So then with Ethers, what's cool is you can do TX weight and then log the transaction here. All right. So let's look at how to do the same thing with Web3.js. So I'm not actually going to refer to the previous tutorial for Web3.js because it's a little bit older and it's a little more complex of a way of doing this. Let's look at a simpler way to do it with Web3. So I'm going to refer to the documentation here. Here's how you do it with Etherjs. So send transaction, Web3 ETH, send transaction, you put in the transaction object and do the callback. It's very similar, but you also need some setup steps to configure your account just like Ethers. So we'll see how you do that here. All right. So you need your private key just like Ethers, and I've just put a fake private key up here. All right, you give it the account. Basically, you convert your private key to an account here. So there's an extra step involved. And you do basically Web3 ETH accounts wallet add, all right, the account. And then you can set the default account in Ethers. So there's some extra setup steps involved here, but it'll still basically it'll just add it to your provider. So that you'll see that theme over and over and again where you do everything on the provider with Web3.js. And then you add your private key to the provider as a default account. And then you can do stuff like send a transaction, which basically looks like the same thing as Ethers over here. Again, there's a little more verbose in Web3.js because you have to do web3.eth.send transaction versus this is just wallet send transaction. But you have to configure your wallet. So there's some trade-offs here. But yeah, this is pseudocode. This is not all going to work if you just copied and pasted it, but this is kind of pulled from the documentation and added to a file with some syntax highlighting so that you can see the differences. All right, so now we're looking at the differences on how you actually interact with smart contracts in Web3.js versus Ethers.js when you're actually, calling a function where you're creating a transaction and writing new information to the blockchain. Okay. So we'll look at Ethers first, then we'll pop over to Web3. So similarly, we've got a situation a lot like our previous example. I'm not going to run this example because I don't want to add the private keys and everything. Again, you can watch the full length tutorial links down below to check that out. All right. But basically, if you're going to write information to the contract, you need 2 pieces of information. You need the ABI, you need the address. So, with Ethers, we saw that you could just paste in a Solidity interface for each function that you want into an array here. A lot of people like doing that. And then you can basically just have the address, which you'd paste in here. And then you'd say new Ethers contract address, ERC20 ABI, and then the provider. That's the same thing we did whenever we read information from the contracts. But let's actually look at, what do you do when you want to write the transaction? Because again, you have to sign this with your private key. Okay, we've added a private key here with our wallet, all right, just like we did in the previous example. But what you do here, this is really common pattern in Ethers is basically you take your contract with the wallet and you connect the wallet to the contract itself. And now this is something people prefer to do with Ethers, but that leaves you with connecting to the contract every time you each contract you interact with connecting the wallet versus Web3, basically just connecting to the provider. There's a little bit of divergence there with the common practice for how you use Ethers. But then basically you just have the contract with wallet, and then you can just call transfer. And that's pretty simple, right? You just pass in the function. You call the function, you pass in the values there, and that's it. You can just wait for it to finish, and then you can wait for the transaction to be mined, and then log out the difference. So let's look at how you do the same thing in Web3.js. So I'm going to pull up Web3's contract. Okay. So creating the contract in Web3.js is the same as we saw in the previous example. You need the ABI, you need the address, you need to add a wallet with, some Ether, wallet with a private key, okay, and then add that to your provider. But let's look at how you actually call the functions. So here's the documentation. I'm going to take some stuff in the documentation and do some pseudocode with some syntax highlighting here on the left. So again, you take the private key, you add the account, all right, you add the wallet, and then you make the default account, just like we saw in the previous example. And then in order to call a function, you take the contract name, and then you do methods, my methods, and then you send, and then you pass in the information like who you're sending it from, okay? So you're going to notice this is, a little bit more verbose, again, than Ethers.js. You have to do contract, methods, my method, and this is where it gets a lot of people hung up, is they do this, and then they don't call send, okay? So, previously, whenever you're reading information from the smart contract, you have to do call to fetch information. And whenever you're doing new transactions, you're writing information, then you have to do send, all right? You can't just call the function that's just going to return the function. You actually have to do send, all right? And if you're doing send from an account, you have to specify that here, okay? Which is kind of some double work, I would say. And then this account has to be added to your wallet in order for that to happen. Okay, so basically you can see how this is a little more elegant, a little simpler, and this is a little more verbose. There's some trade-offs there, but that's an overview of how they are alike and how they are different when you're writing information to the smart contracts. All right, so now let's look at the last example, which is how to read events from smart contracts. So smart contracts will let you emit events inside your functions so that you can, find out about things whenever they happen on the blockchain. You can also look at the entire event history, and that's what we're going to look at right now. So basically, with Ethers versus Web3, so let me get that backwards. This is Web3, this is Ethers. They're pretty similar. Let's look at how they work. So with Web3, you need to connect to the blockchain, just like we've seen before. If you're going to talk to a smart contract, you need the ABI, you need the address, and then create a new contract like this. Same thing for Ethers, connect to the blockchain, ABI, address. But it's important to know that in your ABI for the event, you need to include the event that you want to listen for. I mean, that's true in here too, all right? But we just copied and pasted the entire ABI, which kind of gets us covered. That's why you can see the trade-offs is like, if you're going to do it this way, you got to pull in everything that you need versus this, you can just copy and paste the ABI, all right? And that's going to have everything. Let's see here. You got the address, you got the ABI. Let's look at how you read the events. So Web3, we just do get past events. We can do all events, all right, or we can filter based on the transfer if we want to. We can look at the transfer events. We can tell the from block and then the to block latest, and then we just log it to the console. And with Ethers, we can get the latest block number like this. We can do transfer events, contract query filter, all right, and then do the transfer event and do block -1, which will give us the latest block, and then pass in the block. That's the filter. That's a from block to block. You can see there's less, explicit arguments here. It's not an object. You just pass in arguments one by one, whereas this is an object and you can tell it like from block to block. It's a little easier to read as a developer, which to me, that's kind of a selling point for how Ethers does it. This is a little more, this is a little more intuitive, right? Get past events makes more sense than query filter. So this is a vote in favor of Web3 in my opinion. But that's how you do it in each of them. And that's the main differences. All right, so that's an overview of Web3.js versus Ethers.js, how they're alike and how they're different. So which one of these is best? So, this is a really tricky question because at the end of the day, like there's trade-offs between, Ethers versus Web3.js. Which one do I personally like better? Which one do a lot of developers gravitate towards? Well, definitely Web3.js has a lot of legacy behind it. It was one of the, first libraries to gain a lot of adoption, even though they're both very similar age. Okay. We're seeing lots of people also, migrate towards Etherjs, and you can kind of see why in this video, right? There's some syntax is a little bit simpler. The footprint for the package is nicer. Okay. So me personally, I like them both. All right. I'm kind of moving a little bit more towards Ethers.js. Part of that's a momentum switch, and part of that is because I do make tutorials for other people, is supporting what's popular. Okay. I'd be perfectly happy with just sticking with Web3.js and never changing. I've used it a ton. I'm perfectly happy with it, but I see a lot of benefits towards Ethers.js, and that's, why I'm doing more and more tutorials like that and using it in my own projects as well. So let me know what you think in the comment section below. Which one do you like better, Ethers.js or Web3.js? So that's all I got for today. And if you want to see more tutorials just like this, definitely check out the links down in the description below. You can also go to my YouTube homepage. You can find those free courses there. They're like Udemy courses, but they're totally free. Take one of those. Make sure you subscribe to the channel. Smash that like button down below. That really helps these videos out. So we can learn about blockchain. And, if you like those tutorials and you want to take the next step, or hey, maybe you want to take a master shortcut entirely, I actually become a blockchain master step-by-step, start to finish, over at dappuniversity.com/bootcamp. You don't have to be an expert to get started today. I've helped people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. Until next time, thanks for watching Dapp University.